I am the data manager of the data management team. My name is Takahashi. I would like to make a presentation titled Developing an Internal Service that Monitors the BigQuery data. Let me introduce myself. My name is Hirobumi Takahashi. I joined in MEPE as a data manager since 2022, and in order to provide the most powerful data analysis environment to the analysts in the BigQuery group, I am working really hard day to day. In the BigQuery group, as a data warehouse, we use Google BigQuery. And there are two teams that are involved in the major teams for the data warehouse. There's the data platform team and the data management team. And the data platform team is in charge of the development and operation of the pipeline that delivers data from the service database to BigQuery. And the data management team is in charge of building the systems or process and providing support that allows the users can use data more safely and reassuring and easily. And I will be focusing on the outcomes of this team today. The data management team organizes big data, BigQuery data to promote the use of the data usage. And for example, we use dbt to convert the raw table into interim tables. And we use a GCP managed service, including cloud build and also Argo workflow as a platform to regularly execute dbt. We received several requests from multiple teams internally, and the specific requirements were different for each request, but they were all asking for or receiving a notification if the data is not correct within the BigQuery table. And on the other teams, they were asking for they're using a BigQuery table data to calculate the expenses for the customer companies, but the table's data is not fulfilling the conditions. And the other team was saying that they use BigQuery table data to conduct the point allocation operation for the customers, but they want to be able to detect some of the errors if the points were a mistake, and there were no services that would fulfill this requirement. In order to fulfill the request from two teams, and in order to be prepared for addressing any similar requirements from other teams, we decided to build a monitoring system that can be used across the company. And this will respond to the request of looking for notification when the data is not correct within BigQuery. And the correctness is dependent on the data that is being monitored. And if the data is recognized to be correct, we return 0. And we will have people build a query so that if the result is not correct, the result that is more than one row will be returned. And by executing this query, if the result was more than one row, we would give a notification. And we built this monitoring system with this specification and named it QueryMon and deployed it internally. The first version of QueryMon was 1.0, and that was deployed on Argo workflow. The workflow template that manages the query execution process was prepared. And the process uses a service account name, the query to be executed, in the Slack channel name that will be notified as a parameter. And after the designated service count is impersonated, and after executing the query, if the execution was false, then the message will be sent to the Slack channel. Chrome Workflow has an actual value for workflow template parameter, and it has the role of executing the process and the designated time. Well, this was very simple, but there were several issues. First of all, at the timing where the monitoring should have been done, but the monitoring was not done, and we were not able to notice that. And if there was an issue with the data, the team will be overlooking that issue, and that will be a risk. And next, for the changes on the monitoring target, the QueryMon administrator would need to review this. Monitoring setting was expressed as an Argo Workflows resource, and this resource is changed via CI/CD system, and that required a QueryMon administrator review and approval. And QueryMon administrator has no idea about the domain knowledge, and so we thought it would be better for us to delegate this right to the team. And also, the teams that operate Argo Workflow will be a separate team, so therefore, having higher communication cost in time of troubleshooting was another trouble too. Based on the issue that we saw with version 1.0, we decided to develop version 2.0 that would solve those issues. GCP Cloud Scheduler, PubSub Cloud Functions, and Datadog were used for the deployment. And teams established independent GCP projects, and within that team names, query, essay, name, BigQuery execution project, timeout. Such information was prepared in a JSON format, and we prepared a crowd scheduler job that will publish them into QueryMon PubSub. And the resource is now able to change within the approval by the teams. And PubSub has the cloud functions that is a trigger for that PubSub. And this function is impersonated to the essay that is included in the topic that is published, and execute the query. And the execution result of the query is sent to Datadog as matrix. And if the query result is more than one row, or if it fails, or if the monitoring result doesn't exist for a certain time, Datadog will send a message to Slack. And based on this system, the cloud scheduler job will need to publish a message to PubSub topic. Originally, cloud scheduler supports the jobs that would publish the topic to PubSub, but like with this system, if the PubSub topic is on a separate project, then it will not be available. But this time from the scheduler, by calling the PubSub's publish HTTPS API, we were able to solve that issue. PubSub topics publish API is receiving a parameter of published data as a base 64 encode. And it was very difficult to directly manage this configuration using the Cloud Scheduler UI, and so we decided to manage this by using Terraform. To be specific, like you see on the red wording, by using the Terraform functions, the JSON format data structure using the base 64 encode is created, and by doing so, Terraform resource code is used to make a human-readable way to confirm the monitor configuration. Next, we will set the monitor on Datadog. The monitor is set so that it would send a message to Slack when the metric conditions are viable. Let's say the data more than one row came back. The metric value of a QueryMon monitor result return row count is bigger than 0. And we're able to set the conditions of sending a message using the Datadog query. And by adding the query name and team name on the Datadog query, we are able to select specific teams to send the notification. And in order to detect the timing where the query execution had failed, or we have separate metrics, and set that on the monitor. Right, if the metric that is subject to this monitor doesn't exist for a certain period of time, the alert is issued so that we're able to detect that the monitoring is not working. Version 2.0 compared to 1.0, there are several improvements made. By using the Datadog alert condition function, we are able to find out when the monitoring is not done, and also the monitoring setting is set within the class scheduler within the team, and now the team is able to make changes on the monitoring configuration, and also we are able to set a notification method other than Slack. And the other Teams messaging Argo workflow is no longer used, so therefore the communication cost was lower in case of troubleshooting. On the other hand, there are several issues that are not solved in 2.0. One is that the team, the service account that is not owned by the team can be used to make the QueryMon execute the ad hoc query. QueryMon 2.0 uses a pub subtopic data service account to execute the query, and the team is not able to reject that. And in order to lower the data leakage risk, we have conducted several countermeasures. For example, the publish rights for the pub subtopic can be assigned to the team's service account that was approved beforehand, and also QueryMon's tables data should not be handled. If the monitoring query is successful, we are only able to find it out by the number of rows. And if you set the max result parameter to 0 in the BigQuery query API, the query will just return the number of rows, and the data itself is not returned. And this is very suitable for the specification, so this is what we use. Lastly, this is summary. Well, in order to fulfill multiple requirements of wanting to be able to detect when the BigQuery data is not correct, and we built a monitoring system to monitor the BigQuery data. And I spoke about those actions, and I hope this will be helpful to people with similar issues. And thank you very much for your attention.